So I've got 5 minutes to show you something cool about Python, and specifically something cool about generators. And unfortunately, if I had 5 hours, I could fill the entirety of those 5 hours showing you a lot of cool things you can do with generators, but I only got 5 minutes. So why don't I jump right into it? I want to show you a little helper function that pops up in my presentations, has been popping up in my presentations about Python for years. And it's called nwise. And oftentimes people look at it and they say, what on earth is that gobbledygook? What the heck does that thing even mean? Let me show you the code for it, and then I'll show you why it actually makes a lot of sense. It really actually makes sense how it's constructed and why it's constructed the way it is. Let's take a look. Here, when I write nwise, I always start with, say, from itertools, import islice and t. I say nwise equals a lambda, because, I want to show off and write it all in one line. And what I do is I'm zipping, and that sounds like a good start. You're zipping something, and I'm zipping the islicing of g from I to the n for ig in enumerate t gn. And at this point, a lot of people are like, where on earth did he come up with that? What the heck does that even mean? And then I show you what it does, and I say something like, if we have some structure we're iterating over, for example, the letters A, B, C, D, and F, and we nwise it like this, and we loop over that instead, you can see I get overlapping pairs, A, B, B, C, C, D, D, E, and E, F. And I say that this is a very high performance, very high efficiency little helper function for giving you overlapping windows of some size. And so if I said nwise of size 4, say n equals 4, this is overlapping windows of size 4. If I say nwise of size 3, this is overlapping windows of size 3. Well, I want to show you why this construction is already intuitive, already makes sense to you. And the way I want to show this to you is using a little helper from pandas. Let's say we have a pandas series, and that pandas series contains the letters A, B, C, D, E, and F. And let's print those out to our screen. And let's say that rather than being A, B, C, D, D, and F, it's actually the numbers. Some number of numbers, let's say the numbers from 0 up to 6, and A, B, C, D, E, and F are our index. And what we want is we want to find the pairwise differences. We want to do a diff. And so here, this is the pairwise differences. This is the B value minus the A value, the C value minus the B value. Hold on a second, this is stepping by 1? Yeah, that makes sense. Our range is incrementing by 1. If we made this a range with some stepping, like we said from 0 to 12, stepping by 2, then we should see the pairwise differences being a 2. Well, some people who don't know about diff, you know what they write? They say, instead of the diff, they say shift this by 1 and subtract it from itself shifted by 1. And that's the same idea. You take the values and you shift them by a bit and you subtract them. Well, this is the whole idea behind nwise. What you may realize is if you have some data, and the data looks like these letters, A, B, C, D, E, and F, and you shift this thing by slicing it. You say, take x's and cut off the very beginning. And you match them up by zipping that for window in zipping, x's and x's sliced with its head sliced off, and you print out these windows, you get matched up paired windows. And if you want to do this with windows of some larger size, say 3 elements, you just repeat this by slicing off more elements from the beginning. And if you want to keep doing this, you can just keep doing this. And part of the magic is that zip ends at the shortest of these 3 or 4 or 5 or 6 or 7 copies of the same underlying data. Well, the little trick with nwise is that nwise operates on non-concrete, non-materialized data. It operates on something that is not resident in memory, that might be infinite in size, and as a consequence, it cannot use this slicing notation, because that slicing only works if the thing is a list, a string, a tuple, some sort of concrete data. And so what you have to do is you have to take that data and you have to make transparent buffered copies, because as you go through the elements of these infinite sequences, generators or coroutines or other streams, you can't revisit an element. But T gives you copies which allow you to revisit the elements because they buffer. It identifies how far each of the copies are, and buffers just about enough so that any one of these copies has enough memory to say, oh, you know what? This copy over there is 10 units ahead. I'm 10 units behind. I remember the 10 elements in between. So what I do is I make n copies of this, and I enumerate those n copies. So I say this is the 0th copy, the 1st copy, the 2nd copy, the 3rd copy, and then I slice them. I say for the 1st copy, take 0 elements from the beginning. For the next copy, take 1 element off the beginning. For the next copy, take 2 elements off the beginning, and so forth and so on. So I slice each of these from I to the end, like that. And then you know what? I zip them together, and I have my formulation here for my nwise. I just have to package it up with a lambda, and there you go.